Hi guys, welcome to another episode of MrLopezClasses.com. This is our diesel engine class. This is the chapter 11, the second episode dedicated to the different type of engine cooling systems. We are going to study the three most important cooling systems used in marine engines, inboard engines. Okay, those three systems are raw water system, heat exchanger system, and keel cooling system. Those are the most common. We are going to start with the first one, the raw water system. The raw water system is basically the circulation of raw water internally in the block and the head and goes outside through the exhaust pipe. Every day is less common. It's less common today. Only inboard gasoline engines use some manufacturers use circulation of salt water internally through the block and the head. It's not good. It's good in engines that are used frequently because the circulation of raw water is not stationary internally on the engine, producing corrosion. If the engine is used every day frequently, it's a good system. But if you use your boat only for weekends or 2 weeks, each 2 weeks, it's not recommended. It's better other type of refrigeration like with a coolant and heat exchanger, the second system. But the first system is common in outboards. The majority of the outboards they have a circulation of salt water into the block and the head, and the salt water goes out. All right, but in inboards, a couple of manufacturers use circulation of salt water internally in the block. Some small diesel engines use it in sailboats. They have that system, circulation of salt water. But the new engines use the closed system with heat exchanger and coolant. Can I convert my engine with the raw water system into the system with heat exchanger and coolant? Yes, you can. I am going to explain the procedure. All right, in salt water, for example, in this schematic, the raw water pump. Here is located the raw water pump. This is the raw water pump, and here is located the seacock valve. No, that's the valve, and the raw water enter in the bottom. Okay. And this is the raw water pump. And the raw water pump circulates the water, and the water goes out into the risers, into the manifolds of the exhaust, and goes outside with the smoke at the same time with the raw water. And internally, normally the majority of the engines, they use the circulating pump or coolant pump located in the center of the block. That circulating pump, in this particular case, circulates salt water, no coolant. In this particular case, the engine have two pumps, one raw water pump external and other pump bolted on the block of the engine, the fresh water or circulating pump, in this particular case, work with salt water. Once again, this is a system that every day is less used, especially in inboard, because the salt water corrode the blocks, corrode the head, especially if the block is in steel, is in iron. It's not recommended because the corrosion accelerate the corrosion, and sooner or later the engine have temperature problems. Okay, but this is an example of the typical steam drive system with the lower unit located outside and the inboard located inside. If you see, this is the input. This is the input of raw water. The raw water circulates internally in the block, and finally in the exhaust manifold goes out, and normally goes here directly in the middle of the propeller. Smoke with water. Smoke with water. This is the typical inboard engine. This is an inboard engine with the circulation of salt water. It's common once again in steam drives. Steam drives with the circulation of salt water is very, very common. Can I convert this engine into the next system with heat exchanger? Yes, it's possible. I am going to explain the procedure. It's not complicated. In this particular case, this is a combination of inboard, outboard, the in-out, or a steam drive. But suppose that this engine is not with the steam drive, no steam drive. It's with the shaft, transmission, and propeller. In this particular case, here in this hose goes directly into the strainer, and the strainer goes into the seacock, and the seacock is connected here, and the raw water enter over there. Yeah, and because the engine have a inboard transmission, V-drive, for example. We are going to study this system. But I don't recommend a system with the circulation of raw water, because the corrosion is accelerated. We are going to study later in other book, the book of corrosion, the consequence when the salt water is in permanent contact with the metals. In this particular case, in the elbow, this is the exhaust manifold. This is the exhaust manifold, and this one on top is the riser. Those elements, those are. This is the exhaust manifold. Look, the exhaust port, gases enter over there, and here the gases are in the middle, and the raw water is on the side. Okay, the raw water enter here. Gas enter in the middle, and raw water enter over there. And finally here we have gases, and we have raw water on the side. For that reason, the hose located here connect together raw water with gases. This is the situation. The name of this element is the riser. And this is the exhaust manifold. I have another better picture here. Exactly that, but this is the inconvenient. Those cavities dedicated for the flow of raw water are completely clogged. If you don't use the engine continuously, if you use the engine each 2 weeks, once per month, the salt water close those cavities, and at the end of the day you have a lot of problems. Those are the gases in the middle, and the blue one is the flow of water, and here is located the hose. This is the hose, and those are the hose clamps. And this is the situation. The raw water pass on the blue pad, and the red one is the exhaust gases. This is the riser here. And from the bottom is the exhaust manifold. All right, this is the typical situation. I have an example of how the water circulate in this particular engine. If you see in this video, the raw water passed from the side, and now you can see the raw water here in this on the side, and other one here. Yeah, of course, the hose is located in the external ring. Here is located the hose to connect water with gases together. This is a system, once again, commonly used in inboard gasoline engine. Merck Cruiser use that system, but is less recommended because the corrosion is the enemy of the majority of those elements. Okay, but if you are a marine technician, probably you need attend boats with the circulation of salt water, and you need repair risers, and you need remove exhaust manifold, and you need repair those engines. Okay, you need to be familiarized with the system. Okay, one important element in those engines with the circulation of raw water is the raw water pump, and the strainer, the sea strainer. And we are going to study in this chapter in details what happened with the raw water pump. We are going to disassemble the raw water pump, and we are going to study the raw water pump, and we are going to try to understand the procedure to do the service in a typical raw water pump. We are going to replace the impeller, and we are going to recover the raw water pump. The same with the strainer. We are going to open the strainer, clean the strainer, and check all the information related with the strainer. Okay, this is the typical system. The raw water pump circulate the water, and the water goes out. In this particular example, this engine is connected with a lower unit. No, this engine is connected with a lower unit, and the propeller is here. But there are other ones with transmission and shaft and propeller below under the hull. Okay, and this is the schematic, the typical schematic of that type of engine. Here is the bell housing, the transmission, the shaft, and the propeller. All right, and yes, the most important part is where is located the limit of the water line. Where is located the water line? Because depending on the water line, the raw water pump and the strainer can be installed below the water line. This is the recommendation. They should be installed always below the water line, because doesn't matter if the manufacturer of the raw water pump say that the raw water pump is self-priming, and I don't recommend. I recommend install the raw water pump, of course, and the strainer below the water line, in order to avoid that the pump runs dry and burn the impeller. This is the enemy of the impellers in raw water pump. The enemy is air. If the raw water pump suction air, immediately burn the impeller, and the impeller we are going to study right now is flexible, is in rubber, and if the air enter in the system, immediately the rubber of the impeller is burned, and no raw water pump, no circulation of raw water, and the engine lag for high temperature, and probably is destroyed the engine. Yeah, the enemy of the marine engines is the temperature. Once again, you remember in previous videos I explained you need two gauge working properly all the time. The temperature gauge, the coolant temperature gauge, and the oil pressure. Both of them are critical. You need to check oil pressure and coolant temperature always. Doesn't matter if the engine is gasoline or diesel, inboard or outboard. Those gauges are very important. Okay, this is the typical saltwater system or raw water system. Look at the raw water pump, the strainer, and the seacock. All of them in these particular examples are located below the water line. They should be located below the water line. This is mandatory. It's very important. I'm going to explain the procedure to verify if the raw water is circulating. There are a lot of tips to do that, and a lot of tips to do the service on the system. Okay, the raw water pump, the strainer, and the seacock. And we are going to start right now to study the raw water pump. We are going to see the properties of the raw water pump, the service on the raw water pump, and the same with the strainer. Okay, this is the explanation related with the raw water pump. Okay, guys, the raw water pump is a vital component in the circulation of the raw water. The raw water pump is composed. Normally, the raw water pump is connected with the belt, and is connected with the crankshaft of the engine, with the pulley of the crankshaft. Immediately, you have access to the pump. The first step is check if the pulley is in good condition. If the pulley is no crack, no dent. And the next step is verify if the pulley doesn't have play. If the pulley have play, is because the shaft is broken. If the shaft is broken, normally is because the raw water pump is leaking constantly. This is an indication that the shaft is broken, or the seals internally are broken. Can you replace the shaft and the seals? Probably, but I don't recommend. The raw water pump is not expensive. I recommend replace the raw water pump always. Don't try to fix it. The only that we are going to replace in the pump is probably the pulley, if the pulley is damaged, or the impeller. Right now I am going to explain the procedure to replace the impeller. Okay, check if there are too much leaks. If there are too much leaks, the pump is out. I don't recommend try to fix it. If you have a plate here on the pulley, it's because the shaft is broken. Don't try to replace the raw water pump. All right. You check the pulley. You check the lateral movement on the pulley. You verify the leaks. And right now we are going to check internally. We are going to remove the bolts. We are going to remove those bolts. Those bolts normally are with Allen key, or with a flat screwdriver like this. Be careful because those bolts are special bolts. In other words, the thread is special, the material is special stainless steel or copper like this. This is copper, this is stainless steel, marine grade. I recommend when you work with a pump, try to put a rack and organize all the elements on the rack in order to avoid loose elements, loose terminals. Immediately you remove the plate, you have access to the impeller. As soon as you remove, you need to verify the condition of the impeller. In some cases, the blades of the impeller loose in good condition, but the recommendation is bend it and verify with your fingers that they are not cracked. Bend it and verify that you don't have cracks. I recommend always replace the impeller. Or of course, if the impeller is in good condition, you can try to reuse the impeller. No, that's very important. All right. Immediately you remove the plate. I recommend with a sandpaper. As soon as you remove the plate, with a sandpaper in a flat surface, try to clean the plate properly in order to eliminate the corrosion and the dents on the plate. This is very important. Okay, in order to remove the plate, now we are going to remove the plate in this, in order to remove the impeller, we are going to use this tool. This is a special tool. The tool is recommended. You can buy the tool in any marine storage. And also I recommend, before you disassemble the pump, try to get the part number, the serial number, and use this manual. I love this manual. This is the manual, the catalog of Lewis Marine. Lewis Marine prepared this catalog for all type of pumps. Gasoline pumps, diesel pumps, fuel pumps, raw water pumps, bilge pumps, all type of pumps are in this catalog. This is a good work. Lewis Marine prepared this catalog for pumps with serial number, with part numbers. For example, for this pump, if you have the serial number, you can get access to all the parts, the impeller, the pulley, the gaskets, and you can repair properly the pumps. Please visit Lewis Marine and try to get this catalog, the pumps catalog. All right. Immediately, you have the information related with the pump. You can buy the kit, the impeller kit. The impeller kit is coming with impeller, gasket, and O-ring. Gasket and O-ring. Because in some cases, in some particular cases, like this, you have the gasket, you have the impeller, you have the O-ring, because in some cases, some manufacturers, they use gasket like this, or other manufacturers, they use the O-ring like this. Yeah, O-ring or gasket. For that reason, the majority of the pumps, they comes with both of them, with O-ring and gasket. You need to use one of them, not both of them, one of them. And the impeller. Now we are going to use the specific tool to remove the impeller. We are going to use the tool. Never try to remove the impeller with the screwdrivers, because if you try to introduce the screwdriver here, you damage the housing of the pump. If you make a dent here, after that, when the impeller is working, the impeller is cracked and the impeller is destroyed. Never, never, never try to use screwdrivers to remove the impeller. Use the appropriate tool. Use the appropriate tool. This is the tool. We are going to try to use right now the tool. We are going to close both ends. We are going to close both ends properly. And now we are going to apply pressure in the middle in order to remove carefully the impeller. And right now we have the impeller. The impeller is ready to be replaced. The impeller is ready to be replaced. Be careful when you remove the impeller. Be careful with the half moon. If you see the half moon have a bolt, have a set screw over there. In some cases, when the people remove the impeller, this half moon goes out, and after that, the pump now produce pressure. If you don't have the half moon, you install the impeller, the pump is running, is spinning, but it's not pumping. Why? Because you don't have that depression to produce the pressure. In the picture that I have on the screen, I have the example of why it's important that crescent. That half moon should be located over there in order to create the pressure. Immediately that you remove the impeller from the pump, check with your fingers the quality of the housing. Check that the half moon is firm, is located over there, and check the groove and verify that the groove is clean. And verify that you don't have play on the shaft and the pulley. No play, no lateral play. And verify that you don't have leaks over there. In other words, the seal is in good condition, the half moon is in good condition, and the shaft is in good condition. We are ready to put in back the impeller. What is the other important thing before you install the impeller? Verify that the diameter of the key here is equal to the diameter of the groove in this particular pump. There are other pumps, they don't use the spline and the groove. They use other type of engage procedure. But in this particular case, you need to verify that this diameter is equal to this in order to introduce the impeller properly. There are different type of couplings, and you need verify that the coupling is clean, and use always to install the impeller, use marine grease. The marine grease is a lithium grease. Don't use automotive grease, marine grease. And now you are ready to introduce the impeller again. What is the procedure? You apply grease over there. You apply grease on the blades of the propeller. And now we are going to bend it and introduce the impeller. That's the procedure with grease. And now it's important also with sandpaper clean the face of this area in order to locate properly the gasket. And now you locate the gasket. The pump is coming with this special lubricant to introduce the impeller if you don't have the grease. For the gasket, I recommend apply a little grease in both sides. And after that, install the plate properly, and put the bolts. And tight the bolts in diagonal. 1 bolt, 2, 3, 4, 5, 6, and tight the bolts properly. Tight the bolts properly with the appropriate tool. If it's a screwdriver, with a screwdriver. If it's hexagonal bolts like this, with the Allen key, and tight in diagonal the bolts one per one. And after that, start the pump, start the engine, and verify that you don't have leaks in the bottom. Immediately you start the engine, touch the plate of the pump. At the beginning, the plate is a little hot, but immediately the temperature decreases. This is an indication that the water is circulating on the pump. This is an indication that the water is entering and passing through the pump. The procedure is touch the plate, the temperature increase a little, but immediately goes down. If the temperature no decrease, stop the engine and verify what happened with the impeller. Probably the half moon is not located over there, or the impeller was improperly installed. As soon as you start the engine, you verify that you don't have leaks in the bottom of the pump, that the pump is running properly. If you have a small leak, the recommendation is stop the engine and try to tighten the bolts a little more. If the leak continue, I recommend remove the plate, clean the plate again, putting back the gasket with the grease in both sides, no silicone. Never use silicone because the silicone is not good. The silicone, the impeller suction the silicone and transport the silicone at the input of the heat exchanger and clog the heat exchanger. Be careful with that. Alright, very important, verify that you don't have leaks. Let me tell to you some important information about what is the symptom when the raw water pump is working improperly. In general, when the raw water pump is working improperly, it's because the flow of water outside of the boat is less. If you have two engines, you can verify the flow of water in both engines and verify if the flow is equal at the same speed and is not intermittent, it's not fluctuating. If the flow is less, you have some possibilities. One possibility could be the raw water pump, the impeller damage. Other possibility is that the strainer be clogged. And other possibility is that the heat exchanger internally be clogged. You need to do the service in all of those elements. I'm going to explain later the procedure. Right now, because we are concentrated on the raw water pump, we need to verify if the problem is the impeller. Normally, when the impeller is broken, probably one blade is broken or two blades broken, the flow of water, if you check the flow of water through the exhaust pipe, the flow of water is intermittent, it's not constant. This is a typical indication that one blade is broken. And of course, you need to replace the impeller as soon as possible. I recommend try to keep a couple of impeller kits in your boat, and I recommend try to keep another extra pump spare in your boat. This is very important because if you are in the middle of the ocean, if the pump is broken, you have another pump to replace. I recommend try to keep additional raw water pumps for main engines and additional raw water pumps for generators, both of them. Okay, now this is the theory related with the raw water pump, and we are going to study quickly the theory related with the strainer, the sea strainer. Don't forget that both elements, strainer and raw water pump, both of them should be located below the water line. This is very, 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 very important. I recommend always mark inside of the engine room where is located the level of the water line. Mark with a Sharpie where is located the level of the water line. I explained to you the procedure to verify where is the level of the water line inside of the engine room. Okay, my friends, the strainers. There are different type of seawater strainers, and all of those are if the strainer is marine approved, you can use that strainer. Important thing, If the fitting of my raw water pump is 3/4, of course the fittings in my strainer should be 3/4. If this is 1 inch, should be 1 inch. Half, half. In other words, it's not recommended reductions in the diameter of the raw water pipes. It's not recommended the input in one size and the output in other side. Both of them should be the same diameter, the same size. Both of those fittings should be equal. All right. I recommend plastic, like the strainer that you have on the screen right now, or I recommend a bronze like this. All of those are, if they are marine approved, they are excellent to install in your boat. Okay, if it's metallic like this is fabricated in marine, in a bronze, naval bronze. It's a special alloy. This alloy is resistant for corrosion, but it's important keep the strainer clean. In this moment, this is not clean. The strainer should be completely clean. The idea is that this crystal be completely clean in order to verify if the water is moving, in order to verify if the water have bubbles of air. Remember, the bubbles of air in the strainers are no good, because those bubbles enter in the raw water pump. When the raw water pump is working, compress the water in this area and compress the bubbles of air. And you remember what happened? The bubbles expand and destroy the impeller, produce excessive cavitation on the blades of the impeller and destroy the impeller. For that reason, you need verify periodically when you enter in the engine room if the raw water is moving on the strainers and if the raw water doesn't have bubbles. The bubbles are the enemy. Okay, I am going to explain the procedure to bleed the strainer and eliminate the bubbles. Okay, the typical strainer fabricated in copper like this can be installed. If you check those holes, the strainer can be installed in this position or this position. But in some cases, they have in the labels the letters input and output. Input and output. I recommend follow the recommendation and install the C-cock in this position, because this is the input. Don't forget the diameter of the fitting should be equal all the time. I am going to install the C-cock here, and after that the strainer, C-cock, strainer, and after that the raw water pump. C-cock, strainer, and raw water pump. Don't forget below the water line. This is very, very, very important. Inside of the strainer, if you open the strainer, this gasket is very important. This gasket is very important. You need to keep this gasket in good condition. You can order the kit in order to repair the strainer. The strainer is composed for the gasket, the basket. This is metallic in stainless steel, and the kit is coming with the 2 O-rings, one O-ring on top, other O-ring on the bottom, and with the crystal. In some cases, if you need to replace the crystal for a new one, it's coming. The idea is keep this strainer in perfect condition, completely clean. How can you clean? I recommend clean with water mixed with bleach in order to remove all the corrosion and all the oxidation. And the same with this. You can introduce the basket in a container with bleach and water or barnacle removal in order to remove all of those elements and keep the basket in good condition. Yeah, the basket is located inside, and after that the seal. After that the seal. Don't forget, when you do the service on strainers and raw water pumps, the first step is close the valve. Close the valve in order to do the service properly. Okay, you can replace the gasket, and right now the gasket is new one. The basket internally is new one. the crystal is clean, you open the valve and you verify if the water is moving. If the water is moving, the water enters, and right now you have water in the raw water pump and you can start the engine. I recommend start the engine. Immediately you start the engine, I recommend touch the plate. At the beginning the plate should be a little hot, but immediately the temperature decreases when the engine starts. At the same time, you check if you have bubbles. If you have bubbles on the strainer. If you have bubbles on the strainer, I recommend open a little the top, remove the cap, water is coming out, and tight again. Tight again and verify that you don't have bubbles right now. Okay, this is the procedure to bleed. You lose a little the top, you move it with your hands, water is coming out with air, and right now you tight again, you tight the cap properly, and right now the water is circulating with no bubbles. And right now, of course, the temperature of the plate is cold, is nice, and the engine is running good. When the engine is running, you need to verify if the pulley is moving straight, not bended, and if the belt is properly installed. This is the procedure to do the service on the raw water pump, and the procedure to do the service on the strainer. Other important thing is this, because this element and this element are metallic elements, and they are located below the water line. It's important they have, for example, this is the seacock valve. In the seacock valve you have a couple of screws here. Those screws are used to connect this element to the bonding system. You remember in our electrical class? Of course, those fittings, those strainers, the strainer should be connected from here into the bonding system, like the picture that you have on the screen right now. Those elements in copper should be connected to the bonding system, and the terminals should be properly crimped and properly covered with heat shrink in order to avoid corrosion on those cables. Yes, those elements should be connected to the bonding system. Of course, the block of the engine with this also connected to the bonding system. This is very, very important in order to avoid excessive corrosion on the strainer and excessive corrosion on the through holes. If the through hole and the seacock valve is not properly bonded, connected to the bonding, those elements are eroded faster, and if you have a leak of current through those elements, electrolytic corrosion is accelerated and those metals are perforated, and one day the boat is sank. Be careful with that. The bonding is very important. The bonding is very important, the connection to the bonding. And also, don't forget, try to keep the catalog, because in this catalog you found it all the parts for different type of pumps, sanitation pumps, freshwater pumps, bilge pumps, fuel pumps, all type of pumps. Alright, always use the catalog, verify that all of those elements are connected below the water line, and follow the manufacturer recommendations. Okay guys, I hope that you enjoyed this video. In this video we covered raw water systems, the raw water pump, and the sea strainer. Thank you.